Okay, we're now going to apply the knowledge that you saw in the previous video. So here we go. We have a linear inequality, and that linear inequality is written here, and it says 7x minus 11 is less than or equal to 2x plus 9, where x belongs to the set of natural numbers. At this stage, it is worth writing down what the set of natural numbers actually is. It's a set of numbers 1, 2, 3, going on forever, dot, dot, dot. And what we use to draw on the number line is closed circles. So it's always best to actually do that now. A nice way of remembering that you're using closed circles for this is you've got the dot, dot, dot here. And it just reminds you to only use dots. And that's actually in the formula book, and it's a good way of prompting you. So now we're going to write down what the question says, and it says 7x minus 11. And we're going to go back to early on in second year when we were doing linear equations. And when we were doing linear equations earlier on this year, we were looking at x's moving to the left and numbers moving to the right. So looking at a staying situation, because it's a 7x on the left, and this one has to move, has to go across the other side. The minus 11 has to go across the other side, and the plus 9 can stay where it is. So usually we have that in our heads. So we've got 7x is staying, the 2x is going, so it comes over, becomes minus 2x, is less than or equal to, the minus 11 is going, so it becomes plus 11, the plus 9 is staying, so it stays as plus 9. 7 take 2 is 5, so it's 5x, is less than or equal to 20. When we get down to this point, it's the same as before with linear equations. We're going to divide both sides by 5 because the opposite of multiplying, that says 5 multiplied by x, the opposite of multiplying is dividing. If we divide one side by 5, we must divide the other. So now we're going to have x is less than or equal to 4. Now, once again, it's the natural numbers. So the natural numbers, to remind you, is 1, 2, 3, 4, 5, 6, dot, 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 going on forever. Now what we have here is it says we're allowed in our solution set any value of x which is less than or equal to 4. 1 is less than or equal to 4, 2 is less than or equal to 4, 3 is less than or equal to 4, and 4 is less than or equal to 4, but it's equal to 4. So we've got our 4 numbers. Now, we found the range. That's finding the range of values of x. Now we've actually got to graph our solution set. So to graph our solution set, we need to draw a number line. So there's a number line drawn there. And now on that number line, I want to put numbers. So I've got 1, 2, 3, 4. I can put 5 in, doesn't matter. Here it's going to be 1, 2, 3, 4, 5. But which ones actually apply to my problem? And this one, and 2, and 3, and 4. 5 doesn't count, so I don't put a big dot on it. Okay, that's the end of that. We'll move on to the next example. I need you to pause the video so that you can copy down the example. When you finish copying down the example, start the video up again and study my method and then copy it out. So what we have here is we've got 4, open bracket, x minus 2 is greater than 5, open bracket, 2x minus 1 minus 9. Okay, now we're also going to be using x belongs to the real numbers. For x belonging to the real numbers, based on yesterday's lesson, we're either using a closed circle, an open circle, and then we're using some shading. And it's always worth writing this down, like we did with natural numbers a few moments ago, before you start the question, because it reminds you that you have got to finish by drawing out the shape using these symbols. We should know what a bracket means. A bracket means multiply. So we're going to multiply 4 by x, and we are going to get 4x. Now we're going to multiply the 4 by minus 2, and we're going to get minus 8. We've got a greater than symbol, 5 on 2x, and that's going to give us 10x. And then 5 on minus 1 is going to give us minus 5, minus 9. We go through the staying and going again. This 4x is staying, so we can write 4x. That minus 8 is going across to the other side, so it becomes a plus 8. So we've done that one. The 10x is going left over the inequality symbol, so it becomes minus 10x. And then the minus 5 is on the right-hand side, so it's staying. The minus 9 is staying. So we've finished moving things around and changing the signs appropriately. Now we can work it out. 4 take 10 is minus 6x is greater than, well, 8 take 5 is 3, plus 3. Plus 3 take 9 is minus 6. Now, we've got a minus in front of our algebra. And what you were taught this year was to change signs. And you were also taught change one sign, change them all. Now this is really, really important. If we change one sign, we must change them all. So I'm going to change the minus into a plus, so it becomes plus 6x. The inequality symbol is a sign. I have to change it. What's the opposite of it pointing right? Well, clearly pointing left. So there's the change in that sign. And the change in this sign is going to be a plus. So therefore it's going to be 6. So quick check. I've changed one sign. Yes. Have I changed them all? Yes, I changed that one. I changed that one. I changed that one. Good. Now you're ready to move on. What's the opposite of multiplying by 6? And that is dividing by 6. And now what's 6 divided by 6? Well, the whole point of that was cancel out. And so x is less than 1. So x is less than 1. Now it does say at the top of the page, people often forget to go and look back at the question. Quite clearly states at the top of the page, graph on the solution on the number line. So at the top of the page, it quite clearly says, graph your solution on a number line. So, and that's what we're going to do. It says quite simply here, graph your solution on the number line, and that is exactly what we're going to do. Okay. There's my number line. It's a set of real numbers. So all I need is one reference point, because they've only given me one reference point. So I'm making a mark here and I'm labeling it 1. Based on the previous lesson's work, I've got a less than symbol. And we know that a less than symbol means we have to employ an open circle. So I have to employ an open circle at 1, which indicates the boundary is 1, but it's not equal to it. That says x is less than 1, which means I'm now going to be shading in the bit that's off below it. And because it goes on forever, it doesn't stop, I put an arrow at the end to indicate it goes on forever. Please copy down, well, pause the video, please copy down this example. Thank you very much. Okay, example number 3. Once again, we take a look over here and it says x belongs to z. So we can go to the formula book or we can go from memory. And in the formula book, it will say dot, 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 comma, -3, and then -2, and then -1, and then 0, and then 1, 2, 3, dot, dot, dot. And we know that for z's, all we're ever using is dots to symbolize what the answer is. And again, a bit like natural numbers, the clue is in the formula book. It says dot, dot, dot. So we use dots only. Now looking at the set E. And the set E reads 2x plus 7 is less than or equal to 11. The 7 is moving across, so therefore we are going to change its sign from +7 to -7. And then we're going to get 2x is less than or equal to 4. And then we're going to divide both sides by 2. And then we end up with x is less than or equal to 2. And it says find the solution set. We have found the solution set. It doesn't mention for part 1 that to draw it. It just says find the solution set. Number 2. Number 2 refers to the set H. And the set H is equal to 4 minus 2x is less than 10. I do apologise, I shouldn't have said equal to. I should have used a such that symbol. The the set H is given by 4 minus 2x is less than 10. Now the minus 2x is staying and the 4 is going over to the other side, so it becomes a -4, and then the 10 is staying, so it's +10. So we end up with -2x is less than -4 plus 10, 6. Now once again we have a minus sign at the front. We need to be very wary of this. So we're going back to that mantra again, change one sign, change them all. So we need to change the minus, we need to change the inequality, and we need to change the plus sign in front of the 6. So now what we have is we change the -2, becomes +2x. We change the less than symbol and it becomes the greater than symbol. We change the +6 and that becomes a -6. Now, what's the opposite of multiplying by 2? It's dividing by 2. We do the same to both sides. And so we end up with x is greater than -3. Now, it asks us to find the intersection. It asks us to find E intersection H. Now, the best way to do this is to draw a number line first and have a look at the number line and then draw it and then pick out the answers. It's easier than the way they've asked you to do it. So for part 3, the first thing I'm going to do for part 3 is I'm going to draw the number line. So here we go. There's my number line. So I've drawn the number line and might have to extend it, I don't know. And I'm now going to, I have a tendency to go with the lowest number first. So I've got a choice between -3 and +2. So I'm going to go with -3. And according to this, I need numbers bigger than minus 3. So a number that's bigger than minus 3 is minus 2, minus 1, 0, 1, 2, 3. Now, it says here, starting off with this one, I need x to be bigger than minus 3. So I have to start going up. So if x is bigger than minus 3, then I'm looking at this one here is going to be minus 2, minus 1, 0, 1, 2, 3, and I can just keep going. I could extend that number line a little bit more. And just keep going. And that's that one done. I'm now going to do the x is less than or equal to 2. I'm going to do that in red. And I'm going to do it down below. So what's the boundary point? Is it equal to 2? It is. So I put the red mark on 2. There's also less than it. So it's 1's going to be true. 0 is going to be true. Minus 1 is going to be true. Minus 2 is going to be true. Minus 3 is going to be true. I could extend it. You've got to be very careful. I've done the two sets, which are overlapping, but intersection is basically what do they have in common? So the question was, what do they have in common? So I'm going to draw another solution set, and I'm looking for what they have in common. So where do the blue and the red overlap? Where do they intersect? Well, they intersect at minus 2. They intersect at minus 1. They intersect at 0. They intersect at 1. They intersect at 2. And that's it. They don't intersect at 3. There isn't a red here at 3. There isn't a blue at minus 3. So now, what's my solution set for the intersection? It's where they meet, it's where they intersect, and this is where they intersect. Now, these diagrams here resulting in the black diagram isn't worth many marks in the exam. So if you muck up these drawings, it's not the end of the world. And let's just write over here what we've just worked out. We've worked out the solution graph, the number line graph for E intersection H. Now we're on to the last example. There's two ways of doing it. So the method 1, I would do on the left, and I'll do method 2 on the right hand side. So you've got minus 4 is less than or equal to 3x plus 2 is less than 11. Once again, you're looking at real numbers. Real numbers uses closed circle, it uses open circle, and it uses shaded lines. So I'm going to write that there now too, because you should have learnt that, and going to apply it in a few minutes. Now the technique I'm going to apply here is going back to national school. I want to get rid of the plus 2. How do I get rid of a plus 2? Quite simply, I minus it. So to get rid of a plus 2, I minus a 2. So that I'm calling that the middle zone. So what I'm going to do now, whatever I do to the middle zone, I must do to the first zone, and I must do to the last zone. So now I need to work out what's minus 4 minus 2. Well, it's quite simply minus 6. It's less than or equal to 3x. The reason why we did it is so that these would cancel out, and then we're left with less than 11 take 2 is 9. So the next thing is, I've got 3 multiplied by 6. How do I undo a multiply? I divide by 3. But whatever I do to the middle zone, I must do to the first zone and the last zone. So I must divide by 3 everywhere. When I do that, I end up with minus 2 is less than or equal to x is less than 3. Now, we were not asked to do a drawing, but we're going to do one anyway, just so as to bring a point home. So do copy out the drawing. So I'm just going to draw a number line. So there's my number line. I'm now looking at the boundary points, my number line. So one boundary point is quite simply minus 2. The other boundary point is quite simply 3. Now, I need to look here very carefully. At this boundary point, I have an equal sign. And because I have an equal sign, that's a closed circle. That is a closed circle. There is no equal sign here, so this is an open circle. And the x is in between the two. So because the x is in between the two, what I've got to do now is I've got to do a shaded line in between the two, make it obvious. And there's the picture. Right, then let's have a look at method number 2. In method number 2, again, we write out the question, minus 4 is less than 3x plus 2 is less than 11. What you do for this method is you split them. Minus 4 is less than or equal to 3x plus 2, comma, and then you write 3x plus 2 again is less than 11. So what you do is you split the first and second and write it down on the left, and then you write the second and third and you write it down on the right, and then you solve them. So here we go, we're now going to solve. Bring the 3x over, so it changes sign, minus 3x. Bring the 4 over, becomes a plus 4, and 2 is not moving, so it stays a plus 2. So minus 3x is less than or equal to 6. And now we have to change the signs. And if we change one sign, we change them all. So 3x, so the plus changes, minus changes to a plus. The less than or equal to sign changes to greater than or equal to sign. The plus 6 changes to minus 6. Now we're going to divide both sides by 3. So then we end up with x is greater than or equal to minus 2. And then we do exactly the same thing on the other side. So we've got 3x plus 2 is less than 11. The 2 is moving, so we've got 3x is less than 11. The 2 moves over, so the plus 2 becomes a minus 2. So the 3x is less than 9. Divide both sides by 3, and therefore you end up with x is less than 3. And then you can draw the same number line very much the same way. I think you can guess that I favour method number 1, not least of which is because it's shorter. Now, what you will also see written down here are the questions that I've set you from the exercise. Exercise 7.1, page 50, numbers 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 and 21. There'll be instructions as to how long I want you to spend on this when I post it for you. Okay, thank you.